All right. Thank you everyone for joining today's Premier Wednesday webinar. The name sounds a little different than the normal webinars. This webinar is sponsored by PremierAgile as an organization, and we have been organizing these community events for the last probably 8 years or so. We do a lot of community work, and we used to do these on Wednesdays especially, and hence these are called as Premier Wednesdays. And a request from some of our students and customers has been that, since they are not able to attend on Wednesdays because of their work commitments, they were requesting to do over weekends. And then we started doing these on Fridays and Saturdays and, some of the other days as well. But the name remained the same. Premier Wednesday is like a community platform where we bring industry speakers, students, thought leaders to share their perspectives to the community. And this is edition number 103. We did a couple of interesting sessions as well in the recent past. We did something like, agile in entertainment industry a few weeks ago. We did aerospace based webinar a couple of years back. Siddharth was a speaker there as well. So we do very diverse topics, and we don't just restrict to agile or scrum, right? So today's topic is artificial intelligence in aerospace. And we have one of our youngest speakers today, Siddharth, who is a student in the RV College of Engineering, Bangalore. He will introduce more about himself, but before that, I'm going to take a couple of more minutes. To introduce our organization, PremierAgile. So let's get to the next slide. There you go. Thank you. So about PremierAgile as an organization, is a global company, has been in existence for about 7 years or more. And our mission is to transform organizations. We train, we educate, we coach, transform companies around the globe in both IT and non-IT spaces. We organized more than 1,000 workshops till date. And we are the only organization who is rated at 5 out of 5 by our students globally. And you can check out our website, PremierAgile.com. And you can also check out our Google page as well, that we are rated out of 5 by more than 5,000 learners across the globe, right? So we train, we certify, we transform people in the spaces of Agile and Scrum on how to build better products, how to build high quality systems, how to be more productive, etc., etc. So that's the space that we operate in. And Premier Wednesday has been our community platform where we keep sharing things, we keep sharing knowledge sessions, we bring industry speakers so that audience, our students, our professionals across the globe are going to be benefited. And we do our trainings very differently. Absolutely zero PowerPoint workshop sessions. And that's the USP of PremierAgile, right? So as part of today's topic, without much ado, I'm going to invite our speaker, Siddharth, and he can introduce a little bit more about himself, and he can take us through this exciting topic. As much as you are, I'm looking eagerly forward to learn a lot. All yours, Siddharth. Please go ahead.
Thank you, Suresh. Good evening, everybody. My name is Siddharth Konduru, and I'm a student from RV College of Engineering. I'm currently pursuing a bachelor's degree in aerospace engineering. Some of you might already know me from when I gave a webinar on space systems a few years back for this exact Premier Wednesday event. But I'm here once again to share my knowledge, this time on AI in aerospace. I thank you all for taking your time for attending my webinar on this topic. I know that this is not a field that most of you would be associated with, but I figured I'd just do some general knowledge about some other engineering fields as well. If you take myself, for example, I might be an aerospace student, but I'm personally very fascinated about civil engineering. And I've tried to deepen my knowledge on civil engineering by reading many books in my college library. I've been fascinated with it ever since I studied it in first sem. And that's the thing, like it's all about gaining the general knowledge. And because it never really hurts, and if it fascinates you, then why not dive deeper? So you'll be considered smart since nobody even expects you to know stuff from another field other than your major. But when you pull up with all this general knowledge, you're considered to be very smart. And anyways, with all that being said, we can begin our topic, AI in aerospace. Now, first, let's try to understand what exactly AI, this buzzword, this AI is a buzzword in today's world. What exactly does this mean? And let's dive in. I'm sure many of you are familiar with AI already. AI is the ability of machines to perform tasks that require human intelligence. It includes stuff like problem solving, understanding language, recognizing patterns, and making decisions as well. Now, AI in the technical sense basically refers to four key technologies. So, the first one is machine learning. If you've heard of AI, you might have heard of ML as well. ML stands for machine learning. Basically, ML or machine learning allows a system to learn from the data and it keeps increasing in accuracy over time. You could think of it as a feeding system with past music preferences and teaching. For example, say Spotify, it recommends you the songs, the genre of songs that you have been listening in the past, just in case you like that genre. So the second one we'll be talking about is computer vision. Now, this is how the machines can see and interpret images. A good example would be your phone's ability to unlock facial recognition or apps that can tag people in your photos. Those use this discipline. The third one is natural language processing. This helps AI understand and process the language of humans. For example, whenever you give a prompt to ChatGPT to say, generate this something, analyze this PDF, or explain to me this topic, and this is what enables them to understand the languages that humans are able to speak. And the fourth one that we'll be talking about is reinforcement learning. So in reinforcement learning, it's all about trial and error learning. Think of how you play a video game. You try different actions and see what works out and what doesn't. And based on that, you progress in your game. So that's exactly what reinforcement learning is. It also involves Gen AI, which basically means generative AI. Generative AI, as I spoke before, the AI will generate its own opinions, its own, let's say, like PowerPoint presentations if we need it to generate, or a poster presentation, or something like that. It generates without you giving your own input. You just have to give a prompt, and it generates it. So that's what Gen AI basically means. So let's move on to the next slide. Okay, so we are going to be talking about AI in day-to-day life. So before we actually dive into how AI is utilized in aerospace, let's talk about how AI influences our day-to-day lives as well. I'm pretty sure a majority of you already use chatbots such as ChatGPT, Google Gemini, DeepSeek, whatever, for your school or work or other projects. Or you might also be utilizing stuff like virtual assistants like Alexa and Siri. So these tools, as I discussed earlier, these tools use NLP and ML, so natural language processing as well as machine learning, in order to understand your voice and prompts to execute their tasks. Think about the video recommendation you get from YouTube or Netflix. So these platforms utilize AI to study your behavior, to learn your habits and optimize their settings so that you get the type of videos or movies that you watched in the past, the same genre type of ones. And then the third one is autonomous vehicles. So autonomous vehicles like Teslas, for example, Tesla self-driving cars, they use a blend of computer vision as well as ML in order to navigate safely around the roads. Because as you know, the road traffic it's a very dangerous place, honestly. It's very accident prone as well. So you have to be on spot uh, with your AI, with your coding and all that stuff with your technology. So AI helps in executing all of this. So the fourth one we'll be talking about is smart home devices. For example, thermostats. So what this thermostats means is it's a regulating device. It senses the physical temperature of a system and regulates it to maintain the desired temperature. So some smart home devices like thermostats and security systems are used as well to learn your habits and optimize the settings. That's what AI does with these smart home devices. So we have another example, which is fraud detection. Basically, bank use AI to secure our transactions, um, which is good for cyber security and all that stuff. And another example that is not mentioned here that I would like to share would be aerospace cabins, which is related to aerospace actually, which we'll be getting into soon. Aerospace cabins are becoming more smarter with AI powered climate and lighting as well. So let's move on to the third. Now, before we dive into the actual applications, let's talk about what aerospace engineering means. So basically, aerospace engineering is comprised of two sections, which is aeronautical engineering as well as astronautical engineering. It basically it focuses on the design and development of spacecrafts and aircrafts. So aeronautical engineering basically deals with vehicles that are inbound with the Earth's atmosphere. So basically, all the civil aviation, military aviation, these all come under aeronautical engineering. And then, however, astronautical or aerospace engineering, it it deals with spacecrafts and satellites. So basically, anything that is above the surface or above the atmosphere of the Earth. So this is astronautical engineering deals with those. And aerospace engineering has several important disciplines that one must study in order to actually be able to study aerospace and be able to design and develop aircrafts. So we've got propulsion, which is very important, aerodynamics, studying the flow of air across the aircraft, and then we've got avionics, mixing electronics and aviation. Then we've got structural mechanics, how the structure of the aircraft is affected by the air while airborne, and as well as material science, what kind of materials are most optimal in given conditions and all that stuff. Every component of an aircraft, from its engine to navigation system, has to be designed perfectly and flawlessly. In the present world, however, in the present world, the challenges are growing as people and commercial airlines are looking for fuel efficiency, defense systems are looking for faster response time, and space agencies are exploring deep space missions. And in order to meet the requirements of these challenges, we are utilizing AI. So it's not just a supporting tool, but it is also a core enabler of innovation. And we'll be getting into the connection between AI and aerospace in the next slide. Yes. So let's try to connect AI and aerospace, how AI is utilized in aerospace. So AI So first application that we have is predictive maintenance. So instead of doing routine maintenance checks, AI can analyze sensor data and predict component failures before they ever happen. This reduces the downtime and prevents accidents as well, which is very very useful. And this uses machine learning aspect as well as the reinforcement learning aspect that we have discussed in the previous slides. And the second is autonomous flight. Of course, many of you might have heard of delivery drones, right? So basically, a drone which does not, I mean, basically a delivery which does not require a delivery man, but rather your food or whatever is delivered to you via a drone. So these are being developed. Drones today can navigate terrains, avoid obstacles, and even make decisions midair, thanks to AI. So this is basically utilized, as I said, in Amazon and Walmart. It's still under product and development stage, though, and it can also be utilized in, say, military applications. And the third one we'll be talking about is design and simulation. AI tools can run thousands of design iterations because thousands of design iterations to find the most efficient shape for a new aircraft. So basically, this is obviously useful for reducing the load of the designers as well as the cost. It reduces a lot of cost actually that comes with designing the aircraft manually. Of course, such a thing does require human intervention and human overviews as well because the design is something that is concerned with the passenger's safety. And the design has to be flawless. It should not have any errors at all. Any small error could lead to uh, crash or something devastating, as you've seen in the recent Air India crash. But that wasn't due to the design, really. So the fourth one that we'll be talking about is flight route optimization. So AI adjusts the flight paths in real time to save fuel, and it also avoids weather disturbances and reduces delays, which is important for navigation of these civil aircraft as well as military aircraft as well. Uh, it reduces delays. So what this means is there is something known as latency. That's what the delay actually refers to. So the latency is the delay in between the pilot's message. The pilot sends a message to the ground station, right? So basically, it's a delay between when the pilot sends the message and when the ground station receives the message. The delay can happen due to a number of factors, and this is what latency means. And this latency is reduced by AI. And then we can talk about satellite data analysis. So basically, satellites basically generate large swaths of data. AI can analyze all this data in order to detect stuff like forest fires, uh, climate conditions, or weather climate conditions and their changes as well. Or it can also track military activities as well through these satellites. And now let's talk about the defense systems. So defense is a major part of the country's power. As you all might know, AI is being integrated into tactical decisions making systems and autonomous combat drones as well. These I've talked about this in this slide already, but yeah, these systems can assess threats and respond faster than a human ever could. So let's move. That's the end of the applications for this slide. So let's move on to the next one. And let's talk about the real world case studies. As you can see, there are four companies that I have showcased in this slide. And we'll be looking at how these four companies have utilized AI to achieve their respective missions or to how it helps them with their domains or something like that. So, so let's see. So Airbus Skywise. So Skywise uses AIML to predict maintenance needs, and it also reduces disruptions by 30%. The aircraft uses real-time data from radar and onboard cameras to make independent navigation and landing decisions. So this has like we talked in the previous slide. This utilizes the what is auto the predictive this one flight route optimization, the latency errors, and all that stuff. So then, how does Boeing utilize AI? So Boeing tests AI for fully autonomous flight operations. AI algorithms simulate complex orbital maneuvers, enabling precise and safe docking without human control. So this is very crucial for space station missions. Then we've got ISRO. So ISRO implements AI for autonomous spacecraft docking navigation. Uh, so let's sorry, I mixed up Boeing and ISRO. So Boeing AI algorithms. Uh, one second. Okay, we'll get back to this later. Let's talk about Rolls-Royce now. So Rolls-Royce employs AI for generative design, cutting design cycles by 60%. Their AI platform proposes thousands of efficient component shapes, optimizing weight, cost, and performance simultaneously. Then we've got Delta Airlines. So Delta Airlines uses AI co-pilots for real-time route optimization and it saves 5 to 10% of their fuel. This AI suggests dynamic altitude and speed adjustments mid-flight to avoid headwinds and congested airways. Then we have the European Space Agency, ESA, also known as, processes satellite imagery with 98% accuracy for environmental monitoring. AI identifies deforestation, pollution, and ice melt patterns, enabling faster climate conditions and policy decisions. Then we have the US Air Force Loyal Wingman deploys AI driven drones as autonomous partners. These UAVs or unmanned aerial vehicles can fly in formations, scout enemy position, and act as DKs working alongside human pilots in real time. And lastly, we can talk about DRDO, integrates AI for radar jamming and electronic warfare as well. These systems can counter enemy radar by generating deceptive signals and identifying threats, which is a major part in the electronic warfare. So these innovations aren't just cool, they're massively effective and are saving billions of dollars and improving safety all across the board. So let's move on. So this slide basically talks about the blog that I wrote recently. You can check it out in the PremierAgile website. So the blog is titled "Where is AI? Outlook: Where AI in Aerospace is Headed," and it gives a futuristic outlook where AI in aerospace is headed. You can check it out later if you want after this session. The global AI in aviation market is basically projected to reach $5.5 billion by 2028, growing at 45% CAGR, which is just unprecedented. CAGR stands for Compound Annual Growth Rate for anyone unfamiliar, and it represents the average annual growth rate of an investment in a specific period. This future is not just promising, it is already is taking flight. AI will continue to expand its presence in the following areas. So we have quantum computing first and foremost. Quantum computing is explored to enhance simulation speeds. Quantum computing and AI go hand in hand as well. They basically cover for each other's shortcomings. And this is known as the quantum AI. With that, engineers are able to test materials and design in ways that were computationally impossible before. And the second one we'll be talking about is Edge AI. So Edge AI refers to processing data directly on the device. In this case, the device is the aircraft. It is crucial for real-time decision making, especially in autonomous systems where latency matters, like I discussed earlier about latency. Latency is nothing but the delay that happens between an action taken by the pilot and the corresponding response in the aircraft's control systems or other systems. The third one that I'll be talking about is digital twins. Digital twins are digital replicas of physical systems. So companies like GE use them to monitor aircraft engines in real time. If the digital twin detects an anomaly, it signals a possible issue in the actual engine, which is good for safety of the entire aircraft. And let's move on to the next slide. So let's talk about what AI can do to aerospace field in the future. So the first one is autonomous aviation. Like I said earlier, autonomous aviation drones are being automated for delivery purposes as well as for combat purposes, and air traffic controllers are have to be utilized in order to control around this autonomous aviation and urban air mobility as well. So in urban air mobility, people can utilize their own personal flight vehicles to flights in order to traverse across the town or city. And of course, only rich people would be able to afford this. Then we've got autonomous flight. We've already talked about this. Then we've got predictive maintenance. So digital twins and sensors are able to predict failures and are able to and hence are able to provide the data with the designers or whoever is managing the design, and so that they can stop the failures in time before it actually happens. So let's in space exploration, AI powers autonomous rovers and spacecrafts for distant missions as well. This is again automation, again once again, but this time in the space domain. So let's talk about the space data analysis. So AI enhances climate and disaster monitoring. So this is basically seen in satellites, as I've already discussed. In satellites, the AI analyzes the data that is collected by the satellites, and then processes it, and it detects for all this, such as weather and such climate abnormalities. And then we have, say, space debris is something that is present in the outer space, and it interferes with basic space missions as well as the satellites, natural satellite, artificial satellites that have been put there in order to detect the weather and such stuff. Uh, and it has to be managed properly. And it's also useful for energy efficiency. AI designs fuel efficient aircraft and supports alternative fuels as well. So currently, all of the applications that I have discussed are still in the development and testing stage. So in the future, they will contribute hugely to the development of the aerospace field as a whole, as we are moving towards autonomous aviation, an aircraft which flies without pilots, just like how Tesla is utilizing self-driving cars. Uh, and how is space debris management actually done by AI? Let's touch upon that a little bit. So AI is used to track thousands of space junk pieces that threaten the satellites. And after analyzing and tracking down these junk pieces, it lets the crew know so that the crew can change their attitude in order to escape this uh, space debris, or in some cases they can even outright eliminate the space debris in order to have a uh, smooth journey. And of course, all of these practices and all of these advancements will only get even more advanced as time goes on. So so these are the references this that I have referred. I have pulled a lot of insights from the aerospace, the leading aerospace industries in AI, such as HCL, DXC Technology Insights, um, as well as Space Next Labs. So their research showcases the real world, the development of AI in aerospace from enterprise level applications to advanced space tech. So if any of you are interested in diving deeper after listening to this webinar, I would be more than happy to share you with all the references and all the papers and all the blogs that I have referred to after this session. And that just about wraps it up for this webinar. I've had a great time talking about this topic, and I would like to thank PremierAgile for giving me an opportunity to speak in their event. And of course, thanks to all the viewers as well for attending my session. I hope you found it insightful and interesting. I'll be happy to take any questions that you might have. You can either speak your question and by unmuting yourself, or drop it in the chat, and I'll give you an answer. Does anybody have any questions?
Yeah, Siddharth, thank you for the presentation. So, if any of us are interested in learning, furthermore or exploring the topics, what are some of the, best sites or, learning spaces for us to visit?
So if you want to learn more about this, it's you just have to refer a lot of research papers. There are plenty of research papers online about this, plenty of blogs such as that I have written. I mean, I have written one blog, but there are plenty of blogs like mine that are on the internet, and you can refer to many of them. You can refer to some of those in order
Okay.
to, if you're interested in this. And there's another way, which is uh, you can interact with somebody like an aerospace professor or somebody from the aerospace department. If you're in your locality, if you're interested to talk about these kind of advancements in aerospace, like AI in aerospace and all that stuff.
Okay. Thank you.
Hi Siddharth, thank you for the informative session. I have a question. How does AI process images from satellites?
Okay, that's a good question, Nandan. So satellite data analysis uses AI in a structured methodology, which I'll be talking about. So in data acquisition, satellites first capture the raw data, which can be images, infrared scans, radar data, etc., and they send it to the ground station as well. So the second thing that will happen is pre-processing. So basically, the images are removed of the noise and corrected of the distortions due to atmospheric conditions, and the images are aligned their time series and converted formats so that AI models can utilize and analyze them. So the third one is feature extraction. Here, AI, especially techniques like computer vision and deep learning, steps in to extract the patterns. The fourth methodology is classification and detection. Using AI models, the system can classify regions and detect anomalies as well. The fourth is prediction and decision support. The final step is using this insight for actionable outcomes. This could mean predicting crop yields, forecasting weather patterns, or guiding response efforts after natural disasters. This is the basic methodology behind how satellite generates images and analyzes the data as well. Hope that answers your question.
Thank you for the clarification, Siddharth.
No problem. Anybody else? Any other questions at all?
Okay, so I have something interesting because a lot of students as well ask this question when I also do classes on AI. There's a lot of people are actually worried about how AI is going to, impact the jobs. Well, AI is impacting a lot of human life in a great way, but a lot of people are actually worried that their jobs may go away. So it's not really related to aerospace, but in general, looking at the trends and the effects that it is causing, do you have any, perspective?
Yeah, that is true. That is honestly one of the most debated topics when it comes to AI. And honestly, what I'd say is it depends on how we manage the transition of jobs from human labor to AI rather than the fact that it is actually happening. Yes, AI is automating many repetitive and predictable jobs like data entry, customer service, and even parts of manufacturing, and that can cause job displacement in the short term. Yes, that is correct. Especially for workers whose roles are easily replaced by algorithms and machines, for example, software developers and all that stuff. But, and this is very important, every major technological revolution in history, from industrial revolution to the rise of internet, has caused job shifts, not just total job loss. It's not about jobs disappearing, it's about the jobs evolving. Think about it this way: if ATMs didn't eliminate bank jobs, they shifted the focus from repetitive tasks to relationship management and financial advising. The key for humans is to reskill and upskill. After all, AI is not perfect. It cannot completely act like a human. So the human intervention is required at some point in some areas that AI cannot achieve or do a good job in. So ultimately, is it a good thing or a bad thing? It's a bit of both, but if we handle it thoughtfully, it can be a very good thing for the future. And it's one of the best transformations the humanity has ever experienced. Hopefully that answers your question, Suresh.
Yeah, this is awesome. So thank you so much for that insight, and it's very motivating, in fact, and I'm sure all my students as well will take a lot of positivity from this response. That it's not going to really, affect losing the jobs, but reskilling is, I think, one of the takeaways for me from this discussion.
Yes, it is important to continue to adapt in the face of all these changes,
Yeah.
and the ones who adapt will survive the longest.
Wow. Okay, that's something very resonating so much well with an agile thinking and Scrum, because I also talk about adapting, kind of to the change, to the situation, rather than just being traditional mindset. Which I think adaptation is the key.
Yes.
Great, thank you. Let's check. We have a few more minutes to go. So anyone else has any other question relating to the topic?
Just a sec.
Okay, so I see one question on the chat. So Siddharth, I'm going to read this question. What are the
Okay.
biggest challenges in integrating AI into aerospace systems? Akhil is asking this question. So do you have any insight on this?
Oh, my bad, I didn't see the chat.
No problem.
So, Akhil, integrating AI into aerospace, it obviously presents a lot of exciting opportunities, but it also comes with several major challenges as well. So, as you stated, so some of the challenges that are there are safety and reliability, of course. So, the challenge is that aerospace systems must meet extremely high safety and reliability standards. So, in many AI models, they behave like black boxes and can be unpredictable in edge cases. And the second one is certification and regulation. Regulatory bodies such as FAA and EASA require rigorous certification before new technologies can be deployed. And then regarding AI, certifying AI, especially machine learning models that evolve over time to operate probabilistically, is complex and lacks clear guidance. So an example for that would be an adaptive flight control system must prove it won't fail in unforeseen conditions, which is hard with AI, but it's still doable, though it's still in progress. So the other one is cyber security risks. So increased use of AI and connecting in aerospace systems broadens the attack surface. So as I talked about it earlier, electronic warfare is something that is used during a war. So AI systems can be vulnerable to jamming and data poisoning as well. So an AI algorithm used for predictive maintenance could be fed false data, leading to inappropriate decisions. So the fourth one is data requirement and quality. So training AI requires large, diverse, and high quality data sets. AI issue. In aerospace, such data is often scarce and classified and hard to simulate accurately than human machine interaction. So sometimes pilots can find it difficult to trust AI and understand AI driven systems, and can have difficulty operating it as well because of if the interface is poorly designed and there's a lack of transparency, which can lead to confusion or misuse. So an example regarding this is if a pilot doesn't understand why the autopilot made a certain decision, they may override it inappropriately. And then we'll talk about real-time processing constraints. So aerospace applications often require real-time decision making. So complex AI models might be too computationally intensive for onboard hardware. An example of this would be a satellite AI must process sensor data and make decisions instantly, often limited processing power. And the cost that is required for all this is aerospace systems have long life cycles and expensive hardware. Retrofitting AI legacy aircraft or spacecraft system can technically and financially be challenging as well. However, that is only for integrating and fitting these AI systems into this. During performance, the cost is significantly reduced. And if when you're using AI for the performance, costs such as the maintenance costs are reduced when as compared to when AI is not being deployed. So I think that should answer your question. Those are some of the most pressing challenges with AI. Anybody else with any other questions? It's good to see people are trying to interact and have questions. It tells me that you all have got interest in this topic.
Indeed. Let's check last and final call for questions. Any other interaction that you have, probably you need. You want to make any comments, questions? Okay, no problem. Just don't go away. Last few minutes, all of you.
All right, so if everybody is done with questions, there's just one more thing that I forgot to mention since I've been taking the questions. As you can see, my next webinar, I'll be hosting another webinar on July the 19th, 2025. And this time the topic will be space tourism and exploration. So if you enjoyed my session on this AI and aerospace topic, you feel free to attend that webinar as well. And it will be under the same event of Premier Wednesday.
Nice.
And Suresh can continue.
Yeah. Sure. Yeah, that's one announcement I would like to make. Our next webinar on July 19th. And I'm sure the title sounds very exciting, space tourism. Hopefully, it's going to help us learn a lot of different things about this. And I'm also requesting everyone to kindly mention a few words in the chat. You can write down about a feedback, if at all you have anything to encourage Siddharth and in general Premier Wednesday as a topic, as a platform. If you want to write something, please go ahead and mention a few words. What you felt about the webinar? Did it help you learn something? There are some insights that you have never heard of, or anything that you would like to mention. It'll be very, very glad, and it'll motivate Siddharth as well as us at PremierAgile to conduct these kind of events. Let's take a few minutes, take a few effort to type some feedback for us on this event.
Thank you, Anjum, for enjoying the session. Thank you, Sushant. We'll be hoping to see you again for the next webinar. Thank you, Aruna. Thank you, Venkatesh, as well. Thank you, MED, for the compliment. I'm glad you enjoyed it, Himanshu. Thank you, Sridevi. Indeed, Anish, indeed. It will be, and I'm hoping to see you all again for the next webinar.
All right. Thank you. This is excellent feedback. Very, very motivating, I'm sure, for Siddharth, as much as it is for us at PremierAgile to conduct these sessions and always see if we can help the community in one way or the other for any kind of learning, not just in the Agile space, but a very, very diverse space as well. Thank you so much for joining today. Hopefully, we can also see you once again on July 19th and during the same time. And the topic is going to be a lot more exciting: space, tourism, and exploration. Thank you all for joining. Have a great night. Have a great weekend ahead. Thank you.
Thank you, everybody.